Good morning to one and all. Today we will discuss a topic that is the rank correlation. The previous class we discussed about what is meant by correlation and what are the types of correlations and how we can calculate that Karl Pearson's coefficient of correlation. So let's today we can discuss that rank correlation. So before going to the rank correlation, we need to understand that so how it is different from Karl Pearson's coefficient of correlation. So there is a Karl Pearson coefficient of correlation. What is the need of to study that Spearman correlation? Nothing but why we need to study the Spearman correlations. So that is main thing we need to understand. So instead of the Karl Pearson coefficient of correlation, why we can do this Spearman correlation? See, when the data in the quantitative nature, so we can use the Karl Pearson coefficient of correlation. The data is in the quantitative in the nature. For example, if the data is available in the quantitative, for example, if you take into account your marks, okay. For example, if somebody will give the data about that a qualitative data, qualitative in the sense beauty, okay, that is a taste. For example, if you take into account the taste, nothing but order wise, nothing but ordinal data. So when the data is in the qualitative data, so we can use a Spearman rank correlation. When the data is in the quantitative data, nothing but when the data in the quantitative in the nature, we can use a Karl Pearson coefficient of correlation. So that is the main reason we need to study the Spearman correlation. So basically you can understand easily that why we can use that Karl Pearson coefficient of correlation when the data is in the quantitative in the nature. Then only we can use the Karl Pearson's coefficient of correlation. When the data is in the qualitative in the nature, we can use the Spearman rank correlation. The qualitative in the nature, nothing but beauty, honesty. So there are some variables which we cannot quantify directly. So in that case only we can use Spearman's rank correlation. Then so we need to understand what is the basic introduction of that rank correlation also. So here the rank correlation was introduced by Spearman in 1904. So you need to remember that the rank correlation was given by, nothing but the rank correlation concept was introduced by Spearman in 1904. So the Spearman is a British scientist. Spearman is a British scientist. The Spearman rank correlation, that is R, is used to measure the association between the two variables. Nothing but here also same that rank correlation and Spearman Karl Pearson coefficient of correlation is same, but the correlation meaning is same. But when the data is in the quantitative nature only, we can use a Karl Pearson. When the data is qualitative only, we can use a Spearman. But the correlation meaning is same. The Karl Pearson correlation and Spearman rank correlation. Nothing but we can use this both correlations to study the measure the association between the two variables or more than two variables, x and y or x and y z also. So when use the ranks rather than the precise data, see here the Spearman rank correlation will be used when we use the ranks rather than the precise data. For example, when the data in the present of the quality in the nature, beauty, honesty or taste or preferences. So when the data is in the qualitative only, we can use the Spearman rank correlation. Sometimes they will give the data in terms of precise data, then we can convert into the ranks. For example, they will give the data in the marks, then we need to convert into the ranks. Then only we can do the rank correlation. Then it is based on ranking of different items in the variables. For example, the rank correlation is based on ranking of different items, but where we can give some ranks on the base of their merits. For example, if you take into account marks, so who got highest marks will give the first rank. Then who got least marks, then we will give the last rank. So the ranks, the rank correlation is based on the ranking of different items in the variable, nothing but x variable or y variable. If the researcher is doubtful about the reliability of the data but accept the ordering. For example, see when the person, nothing or researchers is doubtful about the reliability of the data. For example, the person research he has some doubt that about that reliability of the data, whether the data is really or not. So, but accept the ordering. Nothing but we need to give the order. Nothing but we need to accept the ordering. For example, if I take into account that the taste, good, very good, average, like that. So for the base of taste also we can give the order, one, first, second, third. For example, if you take into account beauty, okay, so like that we can give the ordering also. For example, if you take into account xi is greater than xj and yi is less than yj, so then we can use the ranks 1 to up to n number of ranks. Here xi is greater than xj, nothing but the x1 xi is get one rank compared with the xj. For example, if you take into account this xi is nothing but 90, here 85. So 90 is greater than 85, then 90, that 90 marks will get first rank, then 85 marks will get second rank, like that. So we will give the order like 1 to up to n number instead of numerical values on the x and y. So then I will show you that how we can give the ordering also. Then the ranks have to be assigned ordering to size and importance. For example, if you take into account, so how we can give the order, the ranks, how we can give the ranks in our in the form of order, nothing but those size is very high. For example, if you take into account the base of size, the quantity. For example, if you take into account the marks, the 95 is greater than 80 marks. So we will give the 95 is the first one rank, the second one is the next rank. Okay. Then importance, nothing but if you take into account when the beauty competition is going to conduct. So on the base of their importance, the characteristics, they will give the ranks to the different persons. So that is the ranks have to be assigned according to the size and importance. Then the last thing, that is the rank correlation is denoted by RS. RS, nothing but Spearman rank correlation. Last day I told you that correlation indicated with the R, and Carl Pearson coefficient of correlation is denoted by RK, where rank correlation is denoted by RS. The here formula, the simple formula here, R is equal 1 minus 6 sigma d square or 6 summation d square divided by n into n square minus 1. Simple here, you need to remember this is Spearman rank correlation. R is equal 1 minus 6 sigma d square or 6 summation d square divided by n into n square minus 1, or over R is equal to 1 minus 6 sigma d square by n cube minus n, nothing but n into, so when you multiply with this number n into n2, so it can be n cube, then n into 1 n. So it can be write like this also, no problem, doesn't matter. So if you remember anything also, you will get the answer. So where here we need to understand what is 1, as it is we can take it to one number, that is a numerical number, 6 as it is a numerical number, this summation or sigma. So here summation d, nothing but it's a deviation, nothing but a difference between the ranks, nothing but here difference or difference between the ranks of the two variables, x variable or y variable. So after calculating the d, we can square it, that is called d square. Then after calculating the d square, we can add all the d square values, that is called summation d square, Then divide by n is nothing but number of observations, nothing but how many observations we are considering. Then n square minus n. Okay. So here you can write also here, see, this is a difference between the ranks of corresponding values x and y. And you can note down that the R values lies, already I told you in the previous classes, the correlation value lies between -1 to +1, -1 to +1, -1 to +1. That R value is only we will get -1 to +1, -1 to +1. Then you can take a problem, that is, see here, find out the Spearman rank correlation for the following ranks of the two students. So they will ask the question that find out the Spearman rank correlation for the following the ranks of two students. For example, if you take into account data, there is a Beam and Ravan. For example, there are the students Beam and Ravan in a particular class. For example, on the base of marks only, they have given, the teacher has given the ranks to both the students. See, the Beam in the first exam, he got 3rd rank, whereas here the Ravan also got 3rd rank. Then here in the particular examination, the beam has a second rank. Here Ravan has a fifth rank. Then fourth rank and second rank, first rank and first, fifth and fourth one. Then we need to understand that. So in order to find the relationship between the two, or if you would consider as a variable also, x variable and y variable, doesn't matter. Instead of names only, you can take the variables x and y. So this is a formula you need to remember before calculating that rank correlation. That is a 1 minus 6 sigma d square by n into n square minus 1. So as it is 1, so 6. So we need to find out the d first. Then only you can find out the d square. First we d. That is the d is nothing but, I told you that d is nothing but difference between the rank 1 and rank 2. Difference between the rank 1 and rank 2. So that is nothing but d is equal to r1 minus r2. So what is r1 here? Rank is 3. The r2 rank 2. This is not rank 2. This is the variables values, nothing but difference. 3 minus 3, 0. Then 2 minus 5, minus 3. 4 minus 2, plus 2. 1 minus 1, 0. 5 minus 4, plus 1. Then after calculating the d, we need to find out the d square. That is the d square here. 0 into 0, 0. Minus 3 into minus 3. Minus into minus plus 3 into 3, 9. 2 into 2, 4. 0 into 0, 0. 1 into 1, 1. So after calculating that this value, sum of d square value. So here we need to calculate the sum of d square. Sum of d square. So when you add this all the values, you will get sum of d square value. That is called 0 plus 9, 9, 9 plus 4, 13, 13 plus 1, 14. The sum of d square is 14. Then we can substitute in the equation or formula. See here, what r is equal 1 minus 6. As this we can put 6. Summation d square value how much? 6 into 14. 6 into 14. Then divide by n. N is nothing but how many observations we have taken? 1, 2, 3, 4, 5. 5. Then 5 into 5 square minus 1. Then here r is equal 1 minus 6 into 14. How much? 6 4 the 24. 4. And you can put 2, 6 into 1, 6 plus 2, 8, 84. So 84 divided by 5 into 5 square minus 1. So here you can take 5, 5 into 5, 5 square nothing but 5 into 5, 25. So minus 1. So you can write 5 into 25 minus 1. Then you can take next step, r is equal 1 minus 84 divided by 5. You can take 5 as it is, 25 minus 1, 24. The next step, r is equal 1 minus 84 divided by 5 into 24. So 5 into 4, 20, and 5 into 10, 5 into 2, 10. So 20 plus 100, 120. Then 120. So when you cancel it, r is equal 1 minus 84 by 120, you will get 0 0.7. 0 0.7. That is the r is equal 1 minus 0 0.7. So then if you subtract that 0 0.7 from 1, then you will get 1 minus 0 0.7 is equal to 0 0.3. 0 0.3. So it means that the answer is 0 0.3. The rank correlation is 0 0.3. So we can conclude that there is a positive correlation between the two variables, or two variables, that is the x and y, or beam and Ravan. Is it clear, or shall I explain once again?
Clear, sir. It's clear, sir.
What about others? Anirudh and Somnath?
Clear, sir.
Durga Prasad?
Clear, sir.
Sanjana, Niharika, and other. Is it clear now?
Sir. It's clear, sir.
Okay.
Yes, sir.
Okay. If it is clear, then we will go to the next one.
Yes, sir. Okay, sir.
So next one, for example, if you take into account the data for person wise, for example, if you take your class only, for example, if you take the data, the person. So I have collected from 4 people from you only. For example, if you take into account is marks in first semester and marks in second semester. So they will give the marks only. Then they will ask the question that find out the Spearman correlation or Spearman rank correlation. Or simple, they will ask the find out the rank correlation also. Sometimes they will ask that find out the Spearman correlation, or sometimes they will ask the find out the rank correlation, or sometimes they will ask Spearman rank correlation also. So don't confuse it. Okay. So see, for example, they will give the data that is marks in first semester and marks in second semester. For example, if you take one person, for example, if you take, so the person has got 90 marks in first semester. So in the second semester, he got 95. The second person, he got marks 95 in the first semester, and second semester he got 80 marks. Okay. So third person, he got first semester in the 83 marks in first semester and 85 in the second semester. So from I have taken from a fourth person, so he got 16 marks in the first semester and 90 marks in the second semester. But I want to know that what is the relationship between the marks of the particular semesters. Okay. Then I need to go with this formula, that is R is equal 1 minus 6 sigma d square by n into n minus 1. So as I told you that here 6 is nothing but 6 number, 1 is nothing but numerical number, but we need to find the d. D is nothing but what is d here? Hello, you need to respond it. What is d here? D is nothing but the difference between the ranks. Difference between the ranks. But here there is no ranks. Here we need to convert the marks into ranks. Marks into ranks. That is the R1 nothing but regarding to the semester 1. See here, which person has got highest marks in this first semester? Hello? Hello, dear students.
Yes, sir.
You need to respond. So here in the first semester, who got highest marks? Here, the second person, 95. Okay, he got 95 marks. So we allotted that first rank to this person. Okay, then next 90. The first person got 90 marks. So we are given the second rank. Then 83 marks. Then we are given third rank. Then 69 marks. We are given fourth rank. Right? As I say, like that. So we need to give the ranks in the second semester also. See, in the second semester, who got the first highest marks? First person. So we have given first rank to the first person. Then here the fourth person, he got second rank. Then 85, he got third rank. And the second person has got 80 marks now. So he got fourth rank. Okay. So after calculating the ranks in the first semester and second semester, we need to find the D. That is the difference between the rank 1 and rank 2. So here we need to find the difference. That is the 2 minus 1, 1. 1 minus 4, minus 3. And 3 minus 3, 0. 4 minus 2, 2. Okay. Then we need to find the D square. D square. That is called D into D. 1 into 1, 1. Minus 3 into minus 3, minus 2 minus plus 3 into 3, 9. 0 into 0, 0. 2 into 2, 4. So then after calculating the D square, we want to calculate the sum of D square. Sum of D square. That is sum of D square is called how much? 15. So 1 plus 9, 10. 10 plus 4. Sorry, somewhere there is a mistake. Here also 14. Yeah, sorry. Sorry, there's a typical mistake. The 14. Yeah. Yeah. So here the total is 14, right? Yeah. Then here sum of D square is how much? 14 divided by 1. N is nothing but 4 value. 4 square minus 1. Then here 6 into 14 how much? 6 into 14. 6 4 the 24 and 84. So then as it is you can take 4. 4 into 4 16 minus 1. The next step is R is equal 1 minus 84. 84 divided by 4 into 60 minus 1 15. Okay. The next step R is equal 1 minus 84 divided by 4 into 15 60. Okay. Then when you cancel 84 by 60, 84 by 60, you can get 1.4, 1.4. So when you cancel it 1.4, you will get 0.4. So 1 minus 1.4, when you subtract 1 minus 1.4, you will get minus 0.4, minus 0.14, 0.14. Is it clear now? Hello? Hello, dear students. Is it clear now?
Yes, sir.
Yes, sir. Yes, sir. It's clear.
Okay. For example, okay, thank you. Then we will see another problem where, yeah, this is the third problem. See, ranks 5 trainees at the beginning. For example, if you want to know that, for example, you will conduct a workshop, for example, so you want to know that whether there is a relation between the before and after training and before training. For example, you conduct an examination before training, and after a workshop, you may conduct another exam. You want to see that whether there is any relationship between the before and after training. Is there any difference between the before training and after training? Okay. Then here, ranks of 5 trainees, nothing but those who have taken the training at the beginning, X. For example, if you take at the end, Y variable. So a certain course of are given below. For example, if you take trainees, for example, there are 5 persons who have taken the training. So before training only, I have conducted exam. They got the marks. On the basis of marks, I have given ranks. So A person got the first rank, and B person got the second rank, B person got the third rank, D person got fourth rank, the C person is the fifth rank. So before the I conduct a workshop. After conducting a workshop, nothing after training. So I have conducted another exam. But on the basis of their marks, I have given order or ranks. For example, here the D person has got first rank, C person has got second rank, B person got third rank, D person got fourth rank, A person got fifth rank. So I want to know, is there any relationship between the before and after training? Then here I need to follow same formula, that is 1 minus 6 sigma d square by n into n minus 1, n cube minus n. So this is another formula, simple. That is n into n square minus 1 or n cube minus n, same. So same after calculating that ranks, so we need to find out the D. There is a difference. 1 minus 4 minus 4, 1 minus 5 minus 4, 3 minus 3, 0, 5 minus 2, 3, 4 minus 1, 3, 2 minus 4, minus 2. So when you D square, 4 into 4, 16, 0 into 0, 0, 3 into 3, 9, 3 into 3, 9, 2 into 2, 4. So when you add these values, you will get 20 and 38. Sum of D square is 38. Simple, you can substitute this value in the formula. So 1 minus 6 sigma D square, nothing but 6 into 38 divided by n cube, nothing but how many ranks, how many people are there, how many sample are there? Observations, 5 observations. So 5 cube minus 5. Then here 1 minus R is equal 1 minus. So when you multiply 6 into 38, you will get 228. 6 into 38, 228 divided by 5 cube. 5 cube is nothing but how much? 5 into 5 into 5. 5 into 5, 25. 25 into 5. How much? 125 minus 5. 125 minus 5 here. Then next step, R is equal 1 minus 228. 125 minus 5, 120. Okay. Then next step, R is equal 1, 1 as it is, you can take minus, minus. Then when you cancel is 228 by 120. So you will get 1.9, 1.9. So $1.9. So here, after cancelling the 228 by 120, so you will get minus 1.9. So when you subtract from 1 minus 1.9, you will get minus value, that is 0.9, 0.9. So we can conclude that there is a negative relationship between the before training and after training, nothing but. So it means that there is no impact of so there is no impact of workshop or some training on the particular trainees or participants. Is it clear? Hello? Hello, dear students. Is it clear now?
Yes, sir.
See, this kind of variables and this kind of things we will use in the research. For example, if you take into account, so before treatment, after treatment. For example, if you take into account, for example, how they can behavior, nothing but, for example, consumer behavior. For example, if you take into account after service, before service. For example, if you take into account after treatment or before treatment and after treatment. For example, the patient's recoveries or the patient behavior, or for example training. For example, if you take it of class also, for example, so before for example, if you take into account, if you take class also, for example, before class or after class. So before start the class, I may conduct exam. For example, some questions I will ask, so how much you can respond, nothing but how much you got marks. So on the base of marks only I will give the ranks. Okay, so I want to know that after class only whether my class has any impact on the students or not. Think, is there any effect of my class on the particular students? So after class only I will conduct some examination. Nothing but I will conduct exam. Then I will give the marks. On the base of marks I will give the ranks. But I want to know that whether is there any impact of my class on the particular students or not. Okay. So in that case only we can use such kind of this rank correlation in the research field also. Is it clear? Hello? Hello, dear students. Is it clear now?
Yes, sir.
Yeah. So then, for example, see here, see, but here, see, when we are discussing these three examples, but sometimes if the ranks are repeated, for example, same person has got or other people they get same ranks, what will happen? For example, sometimes the ranks may be equal. Nothing but if the two students got same marks, how we can give the ranks to them? That is the main question will arise when the two persons got in equal marks or equal weightage. Okay, for example, if you take into account, for example, if you take IPL exam, for example, if the two people will get an equal marks or equal scores, so how we can give the ranks to them? So here, for example, if you take into account the ranks, if the ranks are repeated, the ranks are repeated. See, X marks and Y marks. For X is the another one person, Y is another person. For example, if you take or subject wise also no problem, doesn't matter. If you take this economic science, public or political science, as you wish. For example, if you take, so in particular examination, these are the people. One person has got 80, 78, 75, 75, 68, 67, 60, 59. So here the two persons has got an equal marks in the particular exam, economics. Okay, but whereas Y, that is a public ad or a public administration. So one person has got 12 marks, another person 13, 14, 14. Here three people has got an equal marks of 14 marks. Okay, the other part 16, 15, 17. Here the two people has got same marks 75, 75. Where Y in the Y subject, the three people has got same marks. What we have to do? How we can give the ranks to them? That is the main question. Then how we can give the ranks in the first one? See, that is R1. So within the X subject, which who got highest marks? For example, you can see in the marks only 80 is the highest marks. So we have given order first rank. Then second highest is 78. We are given the second rank. Then third highest marks is a 75 and 75. How we can give the 75 on third and fourth? So here we cannot able to give the third. For example, if I give this person third rank, the fourth person may be feel that. So Sarah has given third rank to them. That person, why he has not given rank to me, third rank, instead of giving the fourth rank? So meanwhile, so we can give the ranks. That is, so third rank and fourth rank, third rank and fourth rank. What we have to do here, when we have this kind of marks are repeated, so simple we can give that ranks on the base of their marks. How? So this is a give third rank plus fourth rank divide by 2. Third rank and fourth rank is how much? Third and fourth 3 plus 4. How much? 7 by 2. How much? 3.5. 3.5. Then we need to give equal weightage to the both the people. That's why we are given 3.5 rank to the third person and fourth person also 3.5. Then next who got marks highest? 68. So directly we cannot give the fourth rank because fourth rank is included in the third and fourth. Then immediately we need to give the fifth rank. Then sixth rank and seventh rank and eighth rank. Is it understood how we can give the ranks to the when the two students have got equal marks? Durga Prasad and Somnath and other people. Hello?
Sir.
Is it clear? For example,
Yes,
if you take into account here, for example, here I will give another example. See, next is it? Then rank 2. For example, within the Y subject, the public ad, who got highest marks here? 17. So 17 got first rank. Then who was 16 here? Second rank. Then third rank. 15. Who got 15 marks here? Third rank. Then fourth rank. 14 only. So 14. The 14 marks has got 3 people. Then how we can give the ranks to them? Fourth rank, fifth rank, and sixth rank, right? So fourth, fifth, sixth. See, fourth rank plus fourth rank plus fifth rank plus sixth rank. How much you will get? 15. 15 divided by 3 because 3 times the marks is repeated. Same marks 3 times. 15 by 3, how much will get? 5. So that's why we have given a 3 same ranks to the 3 people, right? Is it understood? Okay.
Yes, sir.
Then, so we have used the 4th, 5th to 6th. Then directly we have to give the 7th rank to the 14th marks. Then 12 marks, 8 marks, right? Then after this ranks, same we need to proceed the same formula. There is a deviation, the difference between the rank 1 and rank 2. 1 minus 8 minus 7, 2 minus 7 minus 5, 3.5 minus 5 minus 1.5, 3.5 same 1.5. Here it should be minus 5 minus 5 0, 6 minus 2 4, 7 minus 3 4, 1 minus 1 8 minus 1 7. Then d square 7 into 7 49, 5 into 5 25, 1.5 into 1.5 2.25, 1.5 into 1.5 2.5, 0 into 0 0, 4 into 4 16, 4 into 4 16, 7 into 7 49. Then after calculating the sum of d square total value, we can write sum of d square is equal to 159.5. Okay. Then when the ranks are repeated, the formula is different. Simple, the formula is different. Simple, you can remember that see, little bit is different only. 1 r is equal 1 minus 6 sigma d square. Here it should be placed here plus 1 by 2 into m3 minus m plus 1 by 2 m3 minus m divided by n cube minus n cube minus n. So here simple you can remember, once again I am repeating, you can write clearly 1 minus 6 sigma d square plus 1 by 12 into m cube minus m, okay, plus 1 by 2 1 by 12 into m cube minus m, okay, by divided by n cube minus n. Then simply you can substitute the values. So r is equal 1 minus 6 is nothing but 6. So sum of d square is equal how much? 159.5. Then plus 1 by 12 into m cube, nothing but here same m cube and m cube. In the first, for example, in the first x variable or x subject, how many times the marks is repeated? 2 times. That is called 2 cube minus m is nothing but 2 here. M is nothing but how many times repeated in the x variable, and m here 1 by 12 into m cube minus m. Here what is m cube minus m here? Because it is with respect to the second subject. That is in the second subject, how many times the same marks repeated? 3 times. That is 1 by 12 is equal to 3 into 3 cube minus 3. Is it understood?
No, sir.
See here same 1 by 12 formula, m cube minus m plus 1 by 12 m cube minus m. See here 1 by 12 nothing but here this is a formula 1 by 12 m cube minus m cube minus m and nothing but here in the first variable in the x subject how many times the ranks are repeated or marks are repeated? 2 times, right? 75 and 75. That's why 2 cube plus 1 by 12 here m cube minus m with respect to second variable. How many times the marks are repeated? Same marks 3 times. That is equal 3 cube minus 3. Then r is equal 1 minus 6 6 into 195 by plus 1 by 12 2 cube nothing but how much 2 cube 2 into 2 into 2 2 into 2 4 into 2 8 minus 2 plus 1 by 12 then 3 cube 3 into 3 into 3 how much 3 into 3 9 9 into 3 27 23 then divide by 8 cube nothing but how much 8 cube nothing but 8 is nothing but number of observation. There we have taken 8 observation 8 cube minus n 8 cube minus 8 cube 8 into 8 into 8 8 into 8 63 into 8 5 12 minus 8 then r is equal to 1 minus 6 into 195.5 plus 1 by 12 into 6 8 minus 2 6 plus 1 by 12 26 27 minus 3 24 then r is equal to 1 minus 6 into 159 plus 6 by 12 nothing but 1 into 6 6 by 12 then 1 into 24 by 12 24 by 12 here 24 by 12 you need to write 6 by 12 plus 24 by 12 then r is equal 1 minus 6 6 into 159.5 into when you cancel it 6 by 12 you will get 0.5 so 24 by 12 2 the next step see here then r is equal 1 minus 6 into 159 plus r I told you that see here we need to follow from here 6 sigma d square plus 1 by 2 here it should be plus ekkada ravale so I am unable to write here so books also can understand but here we need to follow see 6 into 159.5 plus 0.5 plus 2 then as you can take is equal 1 minus 6 into when you add these three values 59.5 into 0.5 160 plus 2 162 6 into 162 divided by 515 minus 8 you will get 504 okay then r is equal 6 into 162 972 divided by 504 so when you cancel it 972 so for example if you take 972 divided by 504 that is a 192.8 192.85 so we have taken 192.86 okay so here 1 minus 1.926 you will get minus 0.9286 the answer is minus 0.9286 so we can conclude that there is a negative autocorrelation between the two sub marks